You're welcome to Chapter 7, Product Development, taken from our main topic, Technology Strategy for Managers and Entrepreneurs. Today's learning objectives explain how to identify and prioritize customers' features for new products. It produces a perceptual map, conducts a concept test, examines a collective analysis, and implements the Kano method. It spells out the pros and cons of reducing product cycle time. It explains how to use prototyping, house of quality, design for manufacturing, and web-based tools to improve the product development process. It describes the stage gate process. It defines concurrent development and finally defined modularity. Product cycle time. A product cycle time indicates measures of how long it takes companies to develop new products or services. It reduces product cycle time and helps companies in four ways. Number one, it increases the amount of time the product can be on the market before becoming obsolete. Number two, it speeds the development of product adaptations. And number three, it supports postponing product development efforts until additional information about markets, competitor actions, and complementary technology is released. And number four, it allows the company to capitalize on the advantages of being the first to market the product. With significant senior management support, product development time can be reduced by providing an incentive structure to reward rapid product development, such as focused project teams, influential project leaders, experienced product development teams, independent product development efforts, and external connections. Concurrent development. The process of undertaking some product development steps simultaneously helps companies to reduce product cycle time. It is risky and requires high level of communication between parts of the organization. Concurrent and sequential development. Concurrent development allows all stages of product development to occur at the same time. Sequential development, on the other hand, is associated with high costs and is not efficient since goods cannot be manufactured quickly. As we can see in the diagram, the sequential development has lots of gaps in between its processes, while the concurrent development has a very tight gaps between its processes. Modularity platforms. Modularity platforms are systems made up of separate components that are connected together, and each component completes a single task. It speeds up product cycle time by facilitating customization, by making product development easier, also by reducing costs. Modularity creates cost-based competition, makes product architecture inflexible, and requires technical standards to be developed. Modularity makes the most sense when a product is composed of components that are different from each other, when customer demand is inconsistent, when technical standards have been established, when the pace of technological change is high, when the firms producing different components have very different capabilities, and when the components do not have to be highly integrated. Product platforms. Product platforms are a shared technology foundation to which various features are added to create a family of products, each targeted at different customers. Companies use product platforms to offer more variety to customers without straining organizational efficiencies. Product platforms are used to reduce costs, to facilitate market segmentation, and to reduce product cycle time. Downsides of product platforms. Number one, product platforms reduce product distinctive characteristics. It increases demands for organizational coordination, and it leads to the over-design of low-end products. Identifying the right product features. To satisfy a customer need, one needs to come up with a product with features that are better than the features of competing products at meeting that need. It's not easy done by including every feature that customers might be interested in because it makes the product excessively expensive and difficult to sell to customers with different interests. Conjoint analysis. Conjoint analysis is based on the principle that any product can be broken down into attributes that ultimately impact users' perceived value of an item or service. Conjoint analysis is typically conducted via a specialized survey that asks consumers to rank the importance of the specific features in question. Conjoint analysis typically uses a factorial design to present all different combinations of product features to potential customers. Conjoint analysis input and output. This table indicates the outcome of conjoint input and output analysis. As we can see in the table, we have the inputs of product 1, product 2, and product 3. We also have the input of brands such as Michelin, Tioga, and Electra. We also have the input type, input thread, input weight, and input wear. The same goes to the output product 1, product 2, and product 3. We have output for purchase likelihood. We also have output for standard error. Kano method. The Kano method examines customer preferences for variances in product attributes to assure customer satisfaction when the relationship may not be predictable. The Kano method. The Kano model of customer satisfaction classifies product attributes based on how they are perceived by customers and their impact on customer satisfaction. As shown in the diagram, these classifications help guide design decisions by indicating when good is good enough and when more is better. The three main areas of customer satisfaction are satisfying the basic need that enable a company to enter the market, meeting the performance requirements that enable a company to stay in the market, and finally, is to satisfy the need for excitement that allows a company to excel with a world-class capability. Perceptual mapping. Perceptual mapping is a visual display of customers' perceptions about the different features of competing products. An example of a perceptual map. As shown in the diagram, a perception map is used by companies to map how their customers perceive different items, products, or brands. Collecting aggregated customer data gives an overview of how key users understand the relative positioning of different products or brands within the larger ecosystem. Concept testing. Concept testing is evaluating an idea by target audience before it becomes available to the public. There are 4 varieties of concept testing. Number 1 is monadic testing, which is a single concept. Number 2 is sequential monadic testing, which is multiple concept. Number 3 is proto-monadic testing, which is multiple concepts with a preference at the end. Finally, number 4 is comparative testing, comparing multiple concepts. Product development tools. Product development tools can increase the company's success rate at new product development. Limitations on time and money means that entrepreneurs need to balance the value of using these tools against their financial and time constraints. Web-based tools. Web-based tools provide a cheap and effective way to gather valuable information for product development. House of quality. House of quality is a metric that compares product attributes with customer needs used by companies to ensure that new products have features that meet customers' needs. House of quality. House of quality is a product planning metrics that shows how customer requirements directly impact the actions taken to meet those requirements. The house of quality, as shown in the diagram, resembles the shape of a house and should, if necessary, be created with the direct involvement of customers. Prototyping. Prototyping is the approximation of actual products, including drawings, physical objects, and computer simulations. There are two essential benefits of prototyping. Number one, it allows companies to consider design alternatives before the actual product is developed. Number two, it helps firms to gather accurate information from their customers about their product preferences. It also helps companies to reduce the cost of failure at new product development by encouraging that failure to occur earlier in the development process. Product development process. The product development process covers all the steps required to bring a product from concept to market availability. This includes identifying a market need, studying the competitive landscape, designing a solution, developing a product roadmap, developing a minimum viable product, and so on. In the diagram, we can see how it identifies opportunity when cost is $1,000, how it evaluates opportunity when cost is $10,000, how it designs product when cost is $100,000, how it tests pilot when cost is $1 million, how it develops manufacturing when cost is $5 million, how it tests market when cost is $10 million, and how it scales up production when cost is $30 million. Stage gates. The stage gate process is a methodology that improves project outcomes and prevents risk by adding gates or areas for review throughout the project plan. This framework is most commonly used for product development projects, but is helpful for any complex project. It also restricts investment in the more costly stages of the innovation process until critical milestones have been met. The stage gate process. The stage gate process is divided into 4 principles. The first principle is optimizing the entire innovation process. The second principle is embracing managed risks. The third is accelerating the creative process. And the fourth is option based on decisions. And finally, activating performance through visibility. Design for manufacturing. Design for manufacturing is a set of rules that structure the new product design process to make products easier to manufacture, such as it reduces the number of components, it makes design for easy fabrication, it simplifies tooling and minimizes setup, and finally, it reduces costs of the parts. We have now come to the end of the 7th chapter. Continue to create inspiring technologies and see you in the next lecture.